Hey guys, this video is a continuation of the order of operations that we started up above. If you didn't write this down already, you should write down what the order of operations stands for. We often remember PEMDAS or GEMDAS as we have up in our classroom. And just to review, the parentheses or grouping symbols is what that first step would be when we kind of look for priorities, things we really need to attend to first in simplifying. Exponents would be the next thing. We always would simplify an exponent before multiplying it or adding it or something. And then multiplication and division, and then finally addition and subtraction. So this order of operations isn't listed down here, so make sure you write that down up above where we have a little bit more space. So we're just going to practice a little bit more with circling terms, and remember that terms are numbers that are multiplied together or divided or just single numbers, but if there are multiple terms in an expression, they'll be separated by a plus or minus sign. And this is just a strategy to help us in our simplifying process to make sure that we're following the order of operations and saving addition and subtraction for the last. So here I've circled these terms. This toolkit would be a good one for you to kind of pause, try this on your own, and then check your answer, but you'll notice the problem is actually pretty similar and maybe exactly similar to the one above. So let's go ahead and simplify a simpler version of the problem above. After circling terms, we can simplify them. So if it's just a single number, I just rewrite the number on the next line. And then plus 5 times 3 plus 4 is just like 5 times 7, so I can write plus 35, and then minus 4. And then I can combine terms in any way that I want. So when it's just addition and subtraction, I can just go left to right, and that's a nice, safe way to do it. But also, we know that with addition and subtraction, as long as we're keeping this as minus 4, I can move the negative 6 plus negative 4 together, plus 35, and then I end up with negative 10 plus 35. And it's nice to have tens because it makes our adding easier. So this just simplifies to 25. And showing my thought process would include writing down each step. Now you might say that you want to just do this in your head at this point and skip to 25. As long as you've got, I'd say, as long as you're not going straight to the answer, to just 25 and doing all of this in your head, then I would say you've shown some amount of work as long as this step is here before you get to your answer. So I will be bothering you to show me a little bit more of your thinking than just saying I calculated all of this in my head. So let's go ahead and try step B, which is the second part of the problem on its own. So we're going to circle terms first. This is 2 times negative 7. And look out here, this looks like a minus sign at first glance, but it's actually division. So plus 4 divided by 2 means we're going to be doing those together first. So then I can simplify this to 2 times negative 7 would be negative 14 plus 2, and that gives us negative 12. Now, the second part is kind of what we did above, so I'm going to skip over this a little bit. It says, now simplify the entire expression by first circling terms and then simplifying each term before finally adding and subtracting. Show your steps. So let's do circle the terms. Anything that isn't separated by a plus or minus, and we'll notice there's 5 terms here, so we simplified 3 of them in that first step, so I'm just going to kind of funnel those and point up here. These 3 simplified to 25, and these last 2 simplified to negative 12, and I'll draw an arrow up here. So then we just have 25 minus 12, which equals 13, which we found up above in the previous video. So the final question is, when is the order in which we simplify important and why? And you can pause the video and write down what you think, but really the order in which we simplify is important when there's more than when there's more than just addition and subtraction. When multiplication, we could say when multiple operations are present. So if I had a problem that just involved multiplication, I could multiply the numbers in any order that I wanted. If I had a problem that just involved addition, I could add those numbers in any order that I wanted. And if I had a problem that involved addition and subtraction, I really can still work with that and kind of do things in whatever order I want, as long as I'm subtracting the correct number and not moving that subtraction to other quantities. But when multiple operations are involved, like multiplication and addition, it's important that we follow the order of operations so that, let's see an example. In the example, negative 6 plus 5 times 3 plus 4, it would be really easy for us to want to solve it left to right and to say, well, negative 6 plus 5 is negative 1, and negative 1 times 3 plus 4 is kind of like negative 1 times 7. So to say this equals negative 7. But we know from up here that when I simplify these two things, I have negative 6 plus 35, and that gives me 29. And 29 is quite different than negative 7. So it's important that we follow the order of operations to ensure that we get the same answers as other people, really. So mathematicians kind of established that we would save addition and subtraction for last, and make sure that multiplication, division, exponents, and other things are happening first so that we all get the same answer so that we can communicate with one another and have this language that kind of works. So that's a long-winded answer, but ultimately this would be wrong if we don't follow the order of operations. Multiply before adding. And you can put that in whatever language you want, but do have an explanation. Okay, so that's a little bit more on the order of operations.